Question number 16. In a double slit experiment, the source of monochromatic red light is in slits S1 and S2, okay, separated by distance d. The screen is located at a distance x from the slit, okay, this is called as x. Usually we call this capital D here, okay. A pattern with fringe spacing y is obtained, okay, fringe y is given. See, the moment all these patterns are given, write on the equation. So, y is equal to lambda into capital D divided by small d. We already know this, okay. Now, what's the question here? Three changes are possible for this arrangement: increasing x, increasing d, increasing x, increasing d, okay, using green monochromatic light instead of red. See, when this is given, which means he is talking about the wavelength, okay. So, definitely for red, it will be around 600 nanometers, and for green, it will be lesser than it, okay. Let us say, even if you are not aware of this one, let me take this as something like 500 nanometers over here, okay. So, what changes will cause a decrease in the fringe spacing? So, what is fringe spacing given by y is equal to lambda into capital D by small d. Now, what does it say? Lambda, well, let me write this capital D as x over here. Lambda into capital X divided by small d. Increasing x, what will happen? Y will increase. So, definitely this is not the right one. Okay, because I want decrease in fringe spacing. Then increasing d. If I increase d, what will happen? Numerator, denominator is increasing. Y should decrease. So, this could be the right one. Using green monochromatic light instead of red, it means what? You are decreasing the wavelength. If you decrease the wavelength, what will happen? Y will decrease. So, this is also right over here. So, therefore, the option should be 2 1 3 only. 2 1 3, option is C. Okay. Let us move on to the next one.